Hello everyone. In this lecture, we are going to start with our first chapter of Class 11 Chemistry, that is some basic concepts of chemistry. And our first topic is Law of Chemical Combination. In your syllabus total, you are having your 5 laws. First is the Law of Conservation of Mass. Next is Law of Constant Proportion. Third one is the Law of Multiple Proportion. Fourth is Law of Reciprocal Proportion. And finally, Gay-Lussac Law of Combining Volume. In your syllabus, you have to cover all the 5. In today's lecture, we are going to cover the first and second one. The first, as mentioned, is law of conservation of mass that is given by Antony Lavoisier that states during any physical and chemical change, the total mass of product remain equals to total mass of the reactant. So whenever we write an equation, we first have to write the reactant and afterwards we have to write down the product. After calculating their masses, we'll get to know that their masses are equal. The mass of reactant is equal to the mass of the product. There are multiple experiments done to prove this law. One such here we have is that we have to take a conical flask, and in a conical flask we have to add sodium sulfate. Again we have to take a test tube, and in a test tube we have to take calcium chloride. The mass of calcium chloride is 1.5. Similarly, mass of sodium sulfate is also 1.5. Now we have to remove this thread. Initially we do not have to mix it up. Now after removing the thread, let calcium chloride mix with sodium sulfate. The product we are going to get is calcium sulfate. Along with that, sodium chloride is produced. And after calculating their masses, we'll get to know the mass of product is 3 gram. What is the mass of reactant? It is 1.5 plus 1.5, that is 3 gram. So we can prove the mass of reactant is equals to mass of product. Based on that, an easy question we have is on heating 10 gram of sodium carbonate will get 4.44 gram of carbon dioxide and 5.6 gram of sodium oxide that is produced. Show that this reaction obeys the law of conservation of mass. Here it's very easy. It's 10 gram here given, 4.4 of carbon dioxide and 5.6 of sodium oxide. Mass of reactant given to us is 10 gram. Mass of product is given to us as 4.4 plus 5.6 and total will get 10 gram. Hence prove the mass of reactant is equals to mass of product. The question is, can the law of conservation of mass be violated? Our answer is yes. We'll take one of the example. Here we'll take nuclear reaction. Nuclear reaction. What happened here in this case is the mass is converted to the energy. Hence, it is not following the law of conservation of mass, which means it is violated. Last question of law of conservation of mass we have is how many gram of sodium carbonate are produced if 22.4 gram of NaOH react with 88 gram of carbon dioxide. Here 36 gram of water is produced. Given to us is here NaOH plus carbon dioxide will produce sodium carbonate plus water. What is given to us is NaOH 22.4 gram. A carbon dioxide 88 gram. Na2CO3, let us suppose it to be X and water that is 36. Now let us calculate the mass of reactant. Reactant that is equals to 22.4 plus 88. And on solving we will get 110.4 gram. Now what is the mass of product? It is X because we don't know plus 36. According to the law, we know that mass of reactant that is equals to mass of the product. So mass of reactant is 110.4. Mass of product is X plus 36. What is the value of X now? It is 110.4 minus 36. And on subtracting, we will get 74.4 gram. And that is what our answer. Moving to the next law, that is the law of constant proportion, that is given by Joseph Proust. It states a chemical compound always contains same element combined together in same proportion by mass. Again, this is a very important law. Let us divide this law first. Here it is given to us a chemical compound. So we'll take a compound water. right? They always contain same element. So if I'm taking the water from your home, water from the river, water from rainwater, or from ocean, or from anywhere, the water that is formed is always made up of hydrogen and oxygen. And also they combine in same proportion by mass, which means if I take the ratio of hydrogen to oxygen, and that is constant from where whatever source we are having of water, it does not matter. So here let us take, not let, because we know mass of hydrogen is 1. Here we have total 2 hydrogen, multiplying this by 2. Here mass of oxygen is 16. On cancelling it up, we'll get the ratio 1:8. So the source of water can be anything. It can be river, rain, ocean, anything. But the ratio is constant. That is 1:8 for water. Or if you are breathing it out, you will release carbon dioxide. Or from the forest fire, or from industries, or from coal burning. We're having different source of carbon dioxide, right? The ratio of carbon to oxygen is always constant. First of all, carbon dioxide is always made up of carbon and oxygen. There is no sodium, there is no nitrogen, nothing. So what is the mass of carbon? Mass of carbon is 12 and mass of oxygen is 16. But here we have total 2 oxygen, so I have to multiply this by 2. On solving it up, it is 4 3s are 12 and 4 4s are 16. The ratio is 3 ratio is 8, and that is constant. Next question here we have is there any limitation of the law of constant proportion? And answer is yes. If I will take an example of isotopes, that becomes the major limitation for us. Now, let us take chlorine, because we know the mass of there are two isotopes of chlorine. One is having mass 35 and other is having mass 37, and make a product with, let's say, potassium. So here we'll take KCl. And if I want to find out the ratio of potassium and chlorine, it can be vary. Mass of potassium is 39. One mass of chlorine is 35. Other next ratio of potassium and chlorine, if I'll find, mass of potassium is 39, but chlorine can be 37 because these two are isotopes. Chlorine can exist as 35. It can also exist as 37. These are the isotopes. So here the ratios are not same, and hence it becomes the limitation. Now next question here we have is hydrogen and oxygen combined in the ratio 1:8 by mass to form the water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? Given to us as for 1 gram of hydrogen, 8 gram of oxygen is required. They're asking for what mass of oxygen gas would be required if 3 gram of hydrogen gases we have taken. 3 gram of hydrogen gas we have taken. Mass of oxygen required is 3 into 8 gram of oxygen. 8 3s are 24 gram is our answer. And that is a super easy question. We have to focus on this question because this can be asked in your exam. What is given to us? 1.375 gram of cupric oxide was reduced by heating in a current of hydrogen, and the weight of the copper that remained was 1.098 gram. Given to us as copper oxide or cupric oxide, the mass given to us is 1.375. And the same experiment, the mass of copper given to us is 1.098 gram. Now what we can do is we can easily calculate oxygen here. The oxygen present is subtracting 1.375 minus 1.098. I have already solved it up. We'll get the answer 0.277 gram. Now here we can find the percentage of oxygen in copper oxide, right? What is the mass of oxygen? We have calculated 0.277. What is the mass of copper oxide? That is 1.375. Multiplying this by 100 because we are finding the percentage. On solving, you will get 20.14%. Now same thing you have to follow for the next experiment. You have to find out the percentage of oxygen, and if it is same, then it follows the law of constant proportion. If it is not same, which means it is violating. Now what is given to us in the another experiment? 1.179 gram of copper was dissolved in nitric acid, and the resulting copper nitrate converted to cupric oxide by ignition. The weight of the copper cupric oxide formed was 1.476 gram. Show that these results illustrate the law of constant proportion. Again, what is given to us is copper oxide, that is 1.476. Copper given to us is 1.179. Again, we can calculate the oxygen here on subtracting 1.476 minus 1.179. On subtracting, you'll get 0.297 gram. Next process we have to do is again finding the percentage of oxygen in copper oxide. What is the mass of oxygen? It is 0.297. What is the total mass of total copper oxide? That is 1.476. Multiply this by 100. Again, we'll find up the percentage. On solving, we'll get 20.12. This is very near. These numbers are very near, almost same. So the percentage of oxygen is same in both the above cases. We can say this follows the law of constant composition, or we can say proportion. Same. So that is what we are having in this session. In next session, we'll follow up the rest of the laws. Thank you for listening and have a great day ahead, everyone. Bye bye.